Okay, welcome everybody. So this is React with TypeScript patterns and practices, and I'll just be going over a couple of the main patterns and practices that I use when I'm coding with React and TypeScript, and just the things that I've learned over the time that I've been using it. So here we go. All right, so we'll start with a brief overview of what the presentation will look like. So I'm going to start by describing what React is, just generally, for those of you that maybe aren't super familiar with it. Then I'll follow that up with my general approach to React. So just a couple of things I like to keep in mind when I'm programming with React. And then I'm going to talk about why I use TypeScript and kind of what TypeScript is and what it helps with. And then we're going to get into specific patterns and practices. So we'll talk about folder structure and file organization. We'll talk about imports and exports. We'll talk about component file organization, custom hooks, and managing shared state with React context. And then after that, I'm just gonna, I'll kind of be showing example code for a couple of these points, but we'll do that and then we'll have a Q&A. All right, so let's get started. So what is React? React is a JavaScript library for creating dynamic user interfaces. Simple as that. And it renders based on the state that you provide. So it updates when the state changes. So it's really a data-based UI. It's very different from jQuery where you're explicitly changing things on the DOM. Instead, you just manipulate the data and the DOM updates itself. It's component-based. So you create a tree of components and pass down state via props, which are basically component parameters. Similar to like any properties that you add to HTML, like divs and things. And it utilizes JSX, which is an HTML JavaScript hybrid syntax for rendering components. And you can kind of see an example of that in this little hello world thing here. Okay, so let's talk about my React approach and the things I like to keep in mind when I'm programming with React. So dumb components are a smart approach. We want to keep our React components pretty bare bones, or as much as possible. We want to keep logic and things out of our components. And that's for separations of concerns, you know. We want our components to be kind of the UI layer and to only show what we care about, which is what we're displaying. So we keep business logic and data manipulation out of the UI layer. So the main feature files are only going to contain what we care about, which is what we're displaying. All right. So, and this is an opinionated presentation, but functional components and hooks are the best way to program with React, in my opinion. They're the greatest of all time, the GOAT. Class-based components and higher order components are pretty old-fashioned, you know. They used to be the standard back before hooks came out and React context became useful and functional components became useful. But all of that's changed now. So really there's no reason to use class-based components and higher order component patterns. Functional components keep things clean and succinct. And there's a lot less annoying boilerplate associated with the code, which makes it much more readable for other developers. All right, and so we also want to abstract but leave room for flexibility and customizability. So what I mean by that is just leaving or giving opportunities for other developers to customize the components that you create. So if you're creating a generic React component, you want to provide properties that people can pass in that make sense for customizability. Your component APIs have UX too. So the way that developers interact with your components, there's a user experience associated with that, with the users being other developers. So put a lot of thought into the way that you structure the properties that you pass into your components, because other developers are going to be using them and you want it to be easy to understand and simple to use. All right, so now why TypeScript? So first of all, what is TypeScript? It's a superset of JavaScript. So any valid or any valid JavaScript is valid TypeScript. And it's developed by our pals at Microsoft. We love Microsoft. It allows for stricter typing of JavaScript objects. And it uses kind of a very C-sharp-like syntax and provides us with things like classes and interfaces and inheritance, which is really helpful for just dealing with objects in general, especially when you have an API set up and you are pulling objects from the back end. You kind of want to be able to have that structure in the front end as well. And a bunch more. So why use it? Greatly improves the development experience, in my opinion. When developers come in to a project with TypeScript, it's much easier to see what your objects look like. It's a lot easier to interact with those objects. It makes for much more readable code. It gives us code validation before running our code, which is huge because you don't have that with vanilla JavaScript. So it'll tell you when you're messing up or using an object incorrectly. It allows for auto completion. So there's a lot of tools that you can use, especially with Visual Studio Code, that with TypeScript, you're able to use auto completion. So when you're maybe using somebody else's component and you don't necessarily know what those props look like, if you're using TypeScript, it'll auto complete your props for you. All right, so let's get into patterns and practices now. So let's just talk about the folder structure that I like to use. You can see it over here on the left. Basically, I have a number of folders, each with their own specific purpose. We have assets, and that's just fonts and images and static files. We have our components folder, which is split up into subfolders based on how you kind of want to group your components. And those are shared components across features. We have our context folder, and that's all of our providers, our context providers, and we'll get into that just a little bit later. But anytime you use context, you want to throw your providers in that folder, just easier to find. We have our feature folder, which again is split up into subfolders. And those subfolders of the feature folder are kind of the main navigation pieces. So it should line up directly with your routes or your routes for your application. We have our models folder, which just contains TypeScript models for a bunch of different features. And we have a navigation folder. This was just something I added because I found that there was a lot of navigation specific stuff, and I wanted it to be easy for developers to find where they need to add new routes and things like that. There's a theme folder as well, which contains all of our global SAS theming files. And we have our utilities folder, which is just some shared hooks and helper functions for the most part. Okay. So imports and exports. So we want to define an index.ts file in all of our main folders. And this just really simplifies the import and export process and other files. So what you need to do in that index file is export all the components within that folder that you want to be able to access easily. So here's kind of an example. So we have an index.ts file in one of our folders exporting all of these components. And then in another file, we can import those components all in one line, which is really useful. Without this, you would have to have 3 separate lines just to import each of these components. So that just cleans things up. Okay. Component file organization. Yeah. So I'm just going to show you some code here and we'll talk through kind of how a component file is organized with TypeScript. So let me just go to my editor. Okay. So this is just an example file from the core application we're working on. So up here we have our imports. I always put the SAS imports at the top, and typically it'll be a one-to-one relationship there. You'll have one SAS file for each display component, depending on if it really needs one, because you may not even need one. Then you always want to import React, of course, and then from there it's libraries, like external libraries or npm packages that you're importing from. And then after that, we're importing things from inside our application that we've defined. So after that, we define our type for our props for our component. So in this case, we have label, name, type, a bunch of different things that are props for our component that people can pass in. So followed by that directly, we have our component itself, our component definition. And we use this react.fc, which stands for functional component. This is a TypeScript thing, and it makes things really clean when you're defining your components. So you just pass in the type that you use for your props there. And then this is, JavaScript syntax, the arrow syntax for defining a function. So you can either use const and the arrow function, or you can just use function. But with the const definition, we're able to use this react.fc really easily. And we destruct all of our props that we're going to be using right here. That's another JavaScript thing. It just allows us to pull all of those props directly into variables. And then so within our component, I always start with hooks first. So any hook related things like related to state you want first. And then after that, it's pretty much anything else, like any one-off functions or variables that you need to set based on your props or whatever it is, go after that. And then finally, we have our return, which is, what we're displaying. So that's generally how I set up my components. Now, if say your main component starts to get really large and you have a ton of JSX in here, you'll probably want to split that off into one-off components. So the way I like to do that is, we would just say we wanted to split all of this off. You would define another component below this one, and I don't know, input block content or something like that. And it's kind of the same thing. And we'll just, whatever, return it in there. And then you would use this inside of here. Kind of like that. And you'd probably have to pass some props in or whatever it is. But that's generally how I structure my folders. I think it keeps things clean and readable for other developers. And yeah, okay. So let's go back to the presentation. Okay. So now we want to talk about custom hooks. So first, I kind of want to give a brief explanation of what hooks are, because I know a lot of people don't know this. It's a fairly new construct within React. So basically, it's a set of functions built into React to give access to a couple of different React features inside functional components. It basically makes functional components useful because it used to be that you had to do everything inside of classes, which was very verbose and just it was pretty messy in my opinion. So it allows us to give our functional component state, which means that we can have state values that we update and that update the component itself. It used to be that functional components could only be used as presentational components where you pass props down into them. But with hooks, we're now able to make use of functional components. Okay, so we know what hooks are. So custom hooks are really just hooks that we define that utilize React's hooks. So it's just another layer of abstraction where we can use, one or several of React's hooks to create custom functionality for our components. And it's reusable in all of our components. We can call hooks from anywhere. And it's a great abstraction tool to keep our components dumb and our code dry. And you can have custom hooks within custom hooks within custom hooks because really they're just JavaScript functions. So you can call other functions within functions. It's the same concept, except with these we're using React's set of functions that they've given us to manipulate state. Okay, so React context for shared state. So what is React context? So this is straight from React's website, but context provides a way to pass data through the component tree without having to pass props down manually at every level. So basically what that means is that we can define a state provider, and any component within that provider has access to the state values that we define in that provider. So we no longer have to have, a parent component that passes props down, and we have to pass props down through a million layers just to get access to it at a particular layer. With context, we can have access to our state at any place in the tree without having to pass them down through props. So when do we want to use React context? We want to use it when our component state grows and requires complex data transformations. So if we find ourselves writing a lot of transformational code inside of our components, that's kind of a red flag that we want to maybe define a context and handle it in there instead, keep things cleaner. Another reason you would use context or React context is when you have a complicated component tree where shared data is required at various levels. So kind of what I was talking about before, where maybe you have a bottom level component and you need something that normally you would only have access to at a much higher level component. With context, you can access it. And another reason you would use React context is when you need global shared state. So this is just a way to provide global values to everything in your application. So for instance, like user details, or anything else you could think of. Combined with hooks, context is a very powerful tool for managing state. So I'm just gonna go into a little bit of code now and kind of show you how I organize my context files.
So is this, hi Kyle, Javier here. So is this a replacement for things like Redux or?
Yeah, exactly. So, there are use cases for Redux, I'm sure. But React context does a lot of things that Redux does and pretty much replaces it if you use it correctly. And I really think most applications can do with just React context. That's my opinion.
And also, so I used React briefly for a mobile app using React Native.
Yeah.
But I remember that you used to specify your state within a local state property or something. But now I see that you provided the the props that you're going to use, or I mean the state that you're going to use in your component in this.
So those are actually props. This actually isn't using state. So let me show you in a component that actually does use state. If I can find one. Let me see. So, I mean, these are all using context because, let's see, is there anything? But basically, hooks really simplify your state values. So instead of, like you were talking about, defining your state object in the, like when you're in a class-based component, you would just define your value like this. So value, set value, and then you use state. This is one of React's built-in hooks, and then you pass in the initial state. So let's say it's a Boolean, we can just use false. And then anywhere else in your component, you use, anytime you want to update that value, you just use set value. So that can be used for any pieces of state that you have. You know, you could have as many of those as you want. And then in custom hooks, you can kind of abstract that. For example, let me show you one of our custom hooks. So if we go into our common hooks, you can see something like this has a couple pieces of state where we have like error is loading, a couple of other things. This is in a custom hook, and we can use this hook inside of our components to return the things that, only the things that we need in our component. So in that way, you can abstract your state out to these custom hooks and keep your components clean. That makes sense?
Yeah, okay.
All right, so I was going to talk about context. So let me just go into, our global provider. So context files can get kind of large just because there's a number of things you have to define within them, but don't be intimidated by it. It's really a lot of like copy paste. So once you define one of these context files, you can copy paste and just change the values that you need. So we start off by defining the state that we're providing. So in this case, this is our global state. So we're providing a number of values that we need throughout our application. We have our action types, and those are what we use to dispatch actions to perform different manipulations of our state. We define our actions, which have a type that we define up there, and then a payload. Sometimes you'll have a payload associated with it, where you're sending a certain piece of data to update your state. And then we create our contexts. So in this pattern, and this is something I found just online while I was reading some articles, where we define our state context and our dispatch context. Our state context holds all of our state values, and then our dispatch context is used to, like, when we need to update any of our context values. And the reason we do this and the reason we split it up like this, because you could have both combined into one context, but the reason you might want to split it up is because you may have a component that only needs to update the global state and doesn't need access to the global state. It's not reading values from there, it's just updating it. And we want to do that to avoid additional re-renders, because if you pull down global state and you're not actually using it, you're still going to get re-renders when that global state updates. And so by separating it out into a dispatch context and a state context, we can just use the dispatch context and avoid those re-renders when the state gets updated. So we define our contexts here, and then we define our reducer, which is really just a big switch statement. And inside of here, we're switching on action type. So this is handling when we dispatch a particular action type. So for example, set user, we're creating a user from our payload, and then we're setting that in the state. So we just have to return the new state with the updated values, and that handles the update to the state. And you do that for all of your action types. And then we define our provider. So inside of our provider, we use this use reducer call, and this is what initializes our state and sets up our reducer. So you're passing in your reducing function that we just defined, and then we're passing in the initial state. And when we use that, we get our state and our dispatch returned. So we're grabbing those here. And then here we're using a use effect call, which is another React hook that basically it's just a function that gets called anytime values in the dependency array we pass into it change. So inside of this dependency array, instead of being empty, we could have it dependent on a particular value, and anytime that value gets updated, this function will get called. In this case, we're just initializing some values, so we don't need anything in our dependency array because we only want it called initially when our provider is rendered. Okay. And then we're returning our providers. So we have our state context provider and our dispatch context provider, and you want to nest those and provide the state value to the state context provider and the dispatch to the dispatch context provider. And then down here we're using some hooks, and this allows us to use any of our contexts within any of our components. So anytime you need access to global state, you're just grabbing it with use global state. And it's really that simple. We can find a use case of somewhere we're using that. So for instance, in one of our sub layouts, we're grabbing this value from our global state, which tells us if the sidebar is open. And we just grab it, as simple as that. And this is, kind of a nested component, but we're easily able to access that global state just using that hook. So that was an example of a global provider, but you can also have contextual providers that are only around, pieces of our application that need a particular set of data. So that has a ton. Somebody's echoing. Hold on. That has a ton of implications for things that you can use it for. Like you can use context for pretty much anything you can imagine, and it really helps keep your components clean and handle a lot of the logic outside of your component files. All right, so that is pretty much it. So now I'm just gonna enter a Q&A portion where you can ask questions or any of those other things. Any questions?
Just curious, I'm sorry, yeah, please go ahead.
Oh, okay. Hi, Kyle, this is Rodolfo. Can you talk about some best practices for navigation, or just give us an intro about how you did navigation in this project?
Sure. Yeah. So navigation is tricky. And honestly, this is kind of the first project that I've really tried to make navigation clean. In previous projects, I really didn't know what I was doing. And looking back, um, cringe at the solutions that I provided for it. So in this project, I tried to go with something that was a little more extensible and easy to access. So within our navigation folder here, we have a number of things that help us with navigation. So I have a bunch of navigation types, which is really just classes that I've set up to handle defining routes and subroutes. And then I also have, the routes themselves, as well as some maps and things to easily define those. So for instance, we have our main nav config. This is what is displayed at the top bar of the application where we have access to our dashboard. And really we're passing in a couple of things related to the route, which is, the route itself, the label associated with it, whether or not it's active, and if it's the default route. And then, so these are like the main navigation objects that we're defining here. So anytime you needed a new top level navigation, you would add it there. And then we have subroutes, which is a little bit more complicated. So I decided to go the route of defining these classes with a subroute object where you're basically passing in the route, the label, kind of all the same stuff that you did for the top level things. And then a map where you associate a top level route with these subroutes. So this makes it easy if you change, if you wanted, your subroutes under a different main route, makes it very easy to change just from right here. So, and then I set up navigation helpers. So these are hooks defined to help with navigation. Like for instance, this use navigation hook where this is what determines what's active based on the current route. So we're pulling in the path name, like the URL basically, and then matching that to any of our routes and then setting that particular nav config item as active, which updates the UI. And then our use sub navigation is similar, except we have to grab the kind of the URL context that we're in because it's a subroute and we're appending it to whatever the URL currently is. So we're using some of these, a lot of this functionality comes from React Router DOM, which is just kind of a very popular library for routing that provides us with a bunch of these hooks that give us things like, the current path name, allows us to grab the URL and the route, the current route, and basically utilizing that inside of these hooks to determine what navigation item is active and setting it to default and things like that. It's kind of a lot to digest. I can't really dive into the details of it right now, but that's generally how I have it set up.
Okay, thanks.
Yeah, no problem. Any other questions?
Hey, Kyle, it's Shelly. When you were learning about React and stuff, were there any like blogs or resources or anything that were particularly helpful?
Oh yeah. So actually that's a good point, Shelly. So after this session, I'm gonna send a bunch of links in the main chats of a bunch of resources that I've used throughout my time learning React that were super helpful. And Yeah, a couple of them are where a lot of these patterns came from. And so I'll send those links out and you guys can peruse those at your leisure. But there's a lot of good material out there. There's also a lot of old material out there. So that's something you have to be wary of when you're learning React. Is a lot of it is going to be teaching you class-based components, higher order component patterns, way of doing things, which I feel is not a good way of doing things anymore. And so, but I'll send out some resources and hopefully they'll be helpful to you guys. Any other questions? All right. Well, I'm going to stop it there then. If you have any more questions, feel free to message me on Slack and I'd be happy to answer them. But I appreciate you guys listening. So thanks for coming.
Thank you, Kyle.
Thanks,
Thank you, Kyle.
Thanks, Kyle.
Good day.
Great presentation.
Thank you.
Thank you.
Kyle.
Great chat.